Welcome to the Deep Dive, where we cut through the noise to bring you the most fascinating insights from today's cutting-edge research.
Glad to be here.
Today, we're diving deep into what looks like a real game-changer in artificial intelligence. InternVL 3.5. We've got a stack of detailed sources on this new family of open-source multimodal models, and they're definitely making waves.
They certainly are.
Our mission for you, our listener, is to unpack how these models are pushing boundaries, versatility, reasoning, efficiency, and what that really means for the future of open-source AI.
And what's immediately striking from the research is that this isn't just, a small step.
Right.
InternVL 3.5 feels like a significant leap for open source.
Yeah.
It's directly tackling some of those big challenges in multimodal AI.
Like the gap between open source and the big commercial models.
Primarily that, yes. Narrowing that performance gap is key, and this work seems to make real strides. It feels like a bit of a pivotal moment.
Okay, let's get straight into it then. When you look at InternVL 3.5, what are the sort of big headlines, the standout advancements?
Well, the research really highlights three core areas.
Okay.
Versatility first, then a really noticeable boost in reasoning capability, and finally some pretty impressive inference efficiency gains.
Versatility, reasoning, efficiency. Got it. And these aren't just buzzwords, right? They translate to real improvements.
Oh, absolutely. These represent tangible steps forward that really do place this model family ahead of many other open source systems.
So the sources mention it's designed as a strong generalist. What does that mean in practice for, say, you, the listener, thinking about using something like this?
It means you're looking at a single system that can handle a really diverse range of tasks.
Like what?
Well, things like interacting with graphical user interfaces, GUIs, or acting as an agent in simulated environments.
Okay.
Understanding complex scalable vector graphics SVGs, which is
Yeah.
tricky, and of course, performing advanced text analysis and reasoning tasks.
And the numbers back this up.
They do. The paper specifically calls out a remarkable plus 16.0% gain in overall reasoning performance compared to the previous version, InternVL 3.
16%, that's huge.
It is. And alongside that, a 4.05x inference speedup. These aren't just minor tweaks. It feels like a foundational shift, improving both how smart and how fast these open source models can be.
Let's stick with that reasoning game for a second. 16% is, as I said, huge in AI development. How did they achieve that? What's the sort of secret sauce there?
Yeah, that's where key innovation comes in. The sources call it Cascade Reinforcement Learning, Cascade RL.
Cascade RL. Okay.
And it's not just a label. It seems to be a fundamentally different way they approach the training to make the models, well, reason better.
How does it work? Is it complicated?
It's a two-stage framework. Think of it as refining the model's ability step by step.
Okay, 2 stages. What are they?
So it kicks off with an offline RL stage. They use something called mixed preference optimization, or MPO.
MPO offline.
Right. You can think of this stage as providing a stable warm-up. It efficiently gets the model to a pretty good initial level of performance by learning from a large set of preferred examples.
Like a foundation.
Exactly. Then it moves to an online RL stage. This uses something different, group sequence policy optimization, or GSPO.
GSPO online.
Yes. And this stage is about carefully refining the model's output distribution. It's more like fine-tuning in a live setting, making subtle adjustments to push performance higher, especially on those really tricky reasoning problems.
So it's like learning the basics broadly, then practicing the advanced skills. A coarse-to-fine approach.
That's a good way to put it. This progressive strategy allows the model to improve its reasoning abilities more stably and efficiently.
And the results. Does this Cascade RL actually deliver on those tough benchmarks?
The results seem pretty clear, yes. They report substantial improvements on benchmarks known for being difficult, like MMMU and MathVista.
What kind of scores are we talking about?
Well, the largest model they detail, the InternVL 3.5 241B A28B, hit 77.7 on MMMU and 82.7 on MathVista.
Those are very strong scores, especially for open source.
They are. And the sources suggest this cascaded approach offers better training stability, it's more efficient, and ultimately allows for a higher performance ceiling compared to just trying to do it all in one RL stage. It's a smarter way to teach reasoning, it seems.
Okay, so the reasoning is significantly boosted, but intelligence isn't everything in the real world. Speed matters. You mentioned a 4x speed up earlier. How did they manage that? Efficiency is always a tough nut to crack.
It really is. And it's often the bottleneck for actually deploying these large multimodal models, right?
Definitely.
So the sources point to two main innovations here, both quite clever. The first is the Visual Resolution Router, or VR.
Visual Resolution Router, VR, what does that do?
It's a dynamic system. It essentially looks at an image patch by patch and decides how much detail or resolution is actually needed for each patch to understand it.
So it doesn't just process everything at max detail?
Exactly. It assesses the semantic richness, basically, how important the information in that patch is, and adjusts the resolution down for less critical areas.
Like focusing attention.
Precisely. The impact is significant. It effectively reduces the number of visual tokens the model needs to process by about 50%.
Half the visual tokens? Wow. Does that hurt performance?
That's the clever part. The claim is it maintains nearly 100% of the original performance. So half the visual processing load, virtually no hit to accuracy. That's a big deal for efficiency.
Incredible. Okay, what was the second technique? You mentioned two.
Right. The second one is Decoupled Vision-Language Deployment, or DVD.
DVD. Okay.
This one is more about hardware utilization. It separates the vision encoder, the part that sees the image and the language model, onto different GPUs.
Why do that?
It helps balance the computational load. Vision encoding can be intensive, but happens up front. The language part takes over afterwards. By putting them on separate GPUs, you can run parts in parallel and prevent one part from bottlenecking the other.
Makes sense. Better use of the hardware.
Exactly. The sources say DVD alone can speed up inference by up to 2.01x.
And combined with VR.
That's where you get that overall 4.05x speedup figure we talked about. It's a combination of processing less visual data smartly, VIR, and processing it more efficiently across the hardware DVD.
Very impressive engineering. So we have better reasoning, much faster inference. Let's talk about that first point again, versatility. What specific tasks show off this model's breadth? How does it actually stack up?
Well, the evaluation of the sources is pretty comprehensive. It shows InternVL 3.5 setting a new state-of-the-art among open-source MLLMs across a wide range.
Okay, give us some examples.
First, general multimodal tasks. These are benchmarks like MMVET, OCR bench, where the model needs to understand images, text within images, maybe reason about them together. It shows leading performance there.
Leading among open source.
Yes, and notably, they mentioned the largest model closing the gap significantly with top commercial ones. For instance, across a broad set of benchmarks covering general multimodal, reasoning, text, and agentic tasks, the gap to GPT-5 was apparently narrowed to just 3.9%.
Only 3.9%. That's surprisingly close for open source.
It is. It shows how quickly things are moving. Then there are text-centric tasks.
How does it do with just language? Sometimes multimodal models forget how to talk.
That's a great point, the catastrophic forgetting issue.
Yeah.
But here, the native pre-training strategy seems key. They included large amounts of text-only data during training.
Ah, so it didn't sacrifice language skills to gain vision skills.
Exactly. It outperforms most open-source models on text benchmarks like Math 500, AIM, GPQA, MMLU Pro. It retains strong linguistic capabilities.
Good. What about acting in the world? Agentic tasks.
It shows strong performance there, too. Things like GUI grounding on screen spot understanding and interacting with graphical interfaces. Also, online agent tasks in Osworld G.
And SVGs, you mentioned those earlier.
Yes, it excels in understanding and generating scalable vector graphics on the SGP benchmark. In fact, it achieves state-of-the-art among open-source models for SVG generation.
Even beating commercial models sometimes.
On certain metrics like FID for SVG generation, yes, the sources indicate it surpassed even GPT-4o in some cases. That shows real generative precision.
Impressive. Does this versatility extend to multiple languages?
It seems so. The report highlights significant improvements in multilingual capabilities. They tested across English, Chinese, Portuguese, Arabic, Turkish, and Russian, showing strong gains.
Okay. Anything else stand out in the evaluations?
Two more areas worth mentioning: visual grounding and hallucination evaluation.
Grounding first. What's that?
That's about accurately locating objects in an image based on a text description, like find the red ball. It maintains state-of-the-art performance on datasets like RefCaussy. The largest model scored 92.4% overall, showing high precision.
And hallucinations, always a concern with LLMs.
Right. The sources report consistent improvements in reducing hallucinations compared to earlier InternVL models, which is positive.
But I sense a but.
Well, the authors are transparent. They do acknowledge minor declines in hallucination control on some specific model scales within the 3.5 family.
Ah, okay.
So while it's generally better, ensuring these models are fully trustworthy and consistently avoid making things up is still, an ongoing challenge. It highlights that frontier of reliability.
That makes sense. Even with these huge leaps, that reliability piece, especially compared to closed models with massive human feedback pipelines, is still an area of active work.
Precisely. That 3.9% gap to GPT-5 is amazing, But perhaps some of that remaining difference lies in that robustness and consistency across every possible weird edge case.
Understood. Well, this has been an absolutely fascinating deep dive into InternVL 3.5. It's really clear this isn't just another model release.
No, it feels more significant.
It's pushing the boundaries for open source multimodal AI in some fundamental ways. We've seen how innovations like Cascade RL really boost reasoning.
Getting models to think better, essentially.
And how VR and DVD tackle that efficiency bottleneck, leading to those dramatic speedups.
Which makes them much more practical to deploy.
The consistent outperformance against other open source models and closing that gap with the top commercial players like GPT-5, it really marks a moment.
It does. And the commitment to actually open sourcing these powerful models and the code behind techniques like Cascade, RL, VR, DVD that's incredibly valuable for the whole research community, it speeds everything up.
So for you, our listener, what's the key takeaway? It really feels like the pace of innovation in open source AI is hitting a new gear. Access to these seriously powerful multimodal capabilities is becoming more democratic, driven by smart architectural and training innovations.
Absolutely.
This deep dive hopefully leaves you well informed about where the cutting edge is right now. It shows that open source isn't just catching up, it's innovating in ways that yield major leaps. The question perhaps left hanging is, how quickly can the open community solve that final frontier of deep reliability that we touched upon?
That's the next big challenge, isn't it? Building not just capable, but truly trustworthy AI.
Something to keep watching. Thanks for joining us on the deep dive.